Hi, and welcome to the next segment of the ONF Spotlight on 5G. I'm Timon Sloane with the ONF, and today it's my pleasure to welcome Mavenir, one of the more innovative mobile and RAN vendors. Mavenir has been an advocate for OpenRAN, and we're really pleased to see Mavenir getting more engaged here. So today we have with us Bejoy Pankajakshan. He's the EVP and Chief Strategy Officer with Mavenir. Bejoy, please take it away.
Thank you. First of all, let me thank you from the ONF side for inviting Mavenir to present today on delivering 5G with OpenRAN and end-to-end automation as part of the ONF Spotlight presentations. Given the focus of 5G transformation with open source for the Spotlight session, let me start with a brief introduction of Mavenir, and then I'll cover our end-to-end product portfolio. I'll try to highlight on the key products where open source solutions are used, given this focus on open source. I'll also present different aspects of OpenRAN, the definition, the benefits, and how OpenRAN can be used to deliver solutions today for the macro network, for private networks, and realization of network slices. So finally, let's close with the role of automation in the end-to-end delivery of 5G use cases, because unless automation is tied into this delivery and is a key part of it, we don't see the whole 5G realization actually happen and come to fruition. So quick overview on Mavenir. I won't spend a lot of time on this. Mavenir is an open architecture-based cloud-native end-to-end software provider. Today, we operate in more than 140 countries. We serve more than 250 customers. Globally, more than 3 billion subscribers are on the Mavenir products, including more than 350 subscribers today on NFV OpenStack. We deployed in multiple tier 1 operators in very large scale. Mavenir is around 4,000 employees, and a significant portion of these employees are in R&D. We gained market leadership in the transition from 3G to 4G as we moved from the traditional circuit switch network to supporting voice over LTE deployments. And the industry is now looking at a similar disruption on the radio side. And as you know, radio is the most expensive part of the operator network. And on this front, Mavenir has been leading the OpenRAN initiative. We started actually with the XRAN project prior to ORAN itself being created. We're also very active in TIP and many other OpenRAN initiatives. Now to quickly cover the Mavenir portfolio. We are the only US-based end-to-end network software provider. We're end-to-end because the portfolio includes access, it includes the core, it includes edge computing, IMS core, private networks, as well as the platform and the automation framework that's actually required to manage and run these networks and solutions. The first part is the Mavenir Web Scale platform, and this is an area where open source is used. This is essentially the CAS, the PaaS layer, which we've taken software from CNCF and other open source bodies. On top of the software, we actually build a layer of modifying the software of CAS and PaaS to actually make it telco ready, so meet the requirements of the operators today, the TL9000 requirements that they have for high availability, for making sure that you can meet all the features that telco operators need on their products. So as part of that initiative, we're also working with bodies like XGBella and the CNCF, CNTT initiative for adoption of the software that we build into the open source community. We've always been a strong proponent of open interfaces. We have been developing alternate vendor sources for ORAN-based low-cost radios. The OpenRAN solution from Mavenir also includes the RIC, the Radio Intelligent Controller. And this part of the software actually leverages open source elements as well, and AI ML tools from, for example, Facebook. Botorch is one enabler that we use in the overall framework for RIC. The layer above it is for the actual management and digital enablement, which also leverages open source work, and it leverages work from communities like ONAP, OSM, and the TM Forum. Next, let me quickly cover this difference between ORAN, OpenRAN, and VRAN, because there's generally a lot of confusion between OpenRAN, ORAN, and VRAN, because folks, first of all, use these descriptions very loosely and interchangeably. In some cases, it's actually used purposefully to cause some confusion. So let me take a quick minute to explain the differences. VRAN is RAN, which virtualizes the network function and software platform, running in general purpose processors. And VRAN implementation itself could be open or closed interfaces. Versus ORAN is the actual alliance of operators and vendors, and they create the specifications like 3GPP does today, and they use principles of openness and intelligence. Finally, OpenRAN itself is a disaggregated RAN supply chain, and it's end-to-end system integration. It's an ecosystem that actually consists of the virtualized RAN with all elements of the solution virtualized except the physical radios itself. And then you have the interfaces which adhere to the ORAN specification. The software then runs on open market compute platforms, while the remote radio head could be from third parties. So it allows you the capability to actually mix and get RRU from one vendor and get CU and DU from another vendor. And there's a lot of discussion and innovation happening with third-party rig platforms also coming in and integrating their solutions with XApps and RApps. The RRUs itself being from a low cost third party could mean that you're now replacing the proprietary design with merchant silicon chipsets on these low cost radios as well. So essentially it opens up the supply chain in that regard. Another part is actually is there really momentum behind OpenRAN? So for anybody who's doubting whether OpenRAN is real, this slide is an illustration of the recent momentum for Mavenir's OpenRAN deployments. You'll notice that some of the customer names are not public yet, so I haven't disclosed all the names here, but you can see that there is a global momentum. It starts with some of the public announcements that have been made. In the US, for example, Dish is one carrier who will be live with OpenRAN in at least one market soon. You've got Vodafone UK was another announcement that we did recently where they're carrying the first live traffic of OpenRAN. Earlier this month, I believe it was a couple of weeks ago that they had the press release. There's activity around the globe, and a key factor in making the mobile network economics work for today and for the future is with the OpenRAN sort of deployments, because 60 to 65% of the total cost of ownership of a mobile network comes from the RAN. And the early virtualized RAN deployments have demonstrated significant cost savings here. It's 30 to 50% reductions in capital and operational cost. And this ultimately benefits the customers, and the greater broadband penetration in rural and underserved markets can be achieved as a result of this OpenRAN momentum and by adoption of OpenRAN by tier one and other carriers in their deployment. So, and we're seeing that actually happen. You see operators actually issue RFPs and have OpenRAN as a requirement in that RFP. So traditional closed vendors who aren't adopting OpenRAN-based solutions would get excluded from these RFPs. Another thing is on the OpenRAN system integration momentum. So there's also misunderstanding, which in many cases, in some cases, is intentionally being pushed by players who want to protect the closed radio ecosystem. The false claims here are that OpenRAN will not be successful because of increased system integration cost or difficulty in operation maintenance. I'd say that this is again not true, and it's proven by the ongoing OpenRAN momentum and the prime time adoption of OpenRAN by tier one carriers. Mavenir, we announced the partnership with a few OpenRAN system integrated players. We announced a partnership with Goodman Networks, with GDT, and together we bring more than 75 years of field service experience, which includes 6,000 plus cell site construction, 90,000 plus drive test. And that allows us to actually go and deploy OpenRAN on large scale, and it sort of vets the confusion that's created, the misunderstanding that's created that OpenRAN cannot really scale because the whole system integration piece falls apart. And I'd say that barrier has been addressed by the system integrator and players like Mavenir who play on and take the system integrator role for these OpenRAN deployments. In terms of use cases for OpenRAN itself, we could look at different areas where OpenRAN is deployed today. It's supporting a variety of different use cases. Since the software runs on general purpose hardware and the radios are either developed by Mavenir or by third parties, the advantage is that one key part to this is making sure that the radios that we use are actually being deployed with the full automation scale. So key to actually realizing the full capability of these radios and realizing the cost of this automated network is not just making sure that the radio can deliver on the true RF performance characteristics and anything else that's purely radio related, but there's also the whole responsiveness and the ease of deployment that you need to have with deploying an OpenRAN based solution. So, for example, service management, infrastructure management, orchestration, intelligence, these all become key tenets to actually realize this 5G vision. For example, network slices with radios. This requires network visibility, a deployment ease that's enabled by intelligence and orchestration functions. And a key benefit of cloud-native deployments is the ability to actually optimize resource utilizations during the life cycle of these applications. So to leverage the capability, analytics would play a key role, a major role that provides insights and KPIs, which can then be used for decision-making by these automation orchestration functions. So Mavenir products, including our OpenRAN solution, supports automation, cloud nativeness, telemetry, and observability as foundational design elements in our solution. And we believe this is one of the key differentiators that Mavenir has in an OpenRAN solution, given a pedigree in virtualized deployments and having large-scale NFV deployments. We're able to scale the platform and the solution set and the learnings that we have from NFV deployments in very large scale for our core and IMS-based products today, and take those learnings and apply it into the OpenRAN space, which is all about disaggregated, virtualized open interfaces. So now let's look at a complete network offering for private networks, which is one of the use cases mentioned earlier. So if we look at OpenRAN solution along with the rest of the portfolio, we can deliver private networks, and I bring up private networks because there's a lot of interest with the ongoing CBRS pilot license auctions. Now you could say that for private network deployments, the customers themselves may not care if it's an OpenRAN based solution or a closed solution. At the end of the day, they want a package solution. And we agree with that, but one of the key factors though is to actually roll out those network solutions at the price point and at the scale that's required, and with the friction, or I would say with less friction in these private network deployments, is automation. So automation is what's going to drive the deployment of these capabilities in the private network, whether it's the sectors such as mining or oil, which was a historical sector for private networks, or the expansion into the new sectors of economy like sport venues and manufacturers. So we see this as a key differentiator for Mavenir. And from our perspective, some of the options by which we could actually deploy this is within the enterprise prem itself, as a Mavenir provided private cloud infrastructure, where we provide the hardware, the NFVI, the container layer, the SDN. A second option is deploying it in a Mavenir managed public network cloud, which is then securely connected to the enterprise location. A third option is for the private network applications to be deployed in the enterprise cloud infrastructure that they maintain for OpenStack of containers. And from a solution set perspective, we offer the full portfolio of the 4G and 5G solutions to the private network, whether it's for enterprises or industries or service providers. And what you see here on the slide is the overall solution that's broken down into a few layers. Starts with the radio and packet core, and you can optionally have other applications as well. Above this layer is the automation framework for the radio and the core. And finally, the last layer is important because it allows the network operator to actually have a good way to extract out the complexity of the underlying network that includes the radio, the core, and create digital app store for enterprises and industry applications. So seamless onboarding, kind of think of it as an enterprise or a digital marketplace for enterprise and customers, and also has the capability to now expose device and network insights combined with subscription management capability of the overall solution. So this is the first use case that I want to talk about. Another one is, okay, how do I actually use this private network deployment to, as a use case, support neutral host or multi-operator service deployments? We have a similar solution now for one of the carriers in UK, actually using the solution, and it's showing a sample deployment of this neutral host infrastructure and how we could leverage OpenRAN and virtualized technology to realize this neutral host deployment. So setup that's shown here is actually for 3 operators. 2 of them could be regular mobile network operators. And one of them in this case is Mavenir itself running services as a hosted offering. So the private network offering that I mentioned in the previous slide could be the third carrier that's shown here, and it's actually operated and run by Mavenir. In the drawing here, what we have is a multi-band RRU, so it supports all the required bands for the solution. And using the OpenRAN interfaces, we then connect to the software part of the radio, the CUDU. The virtualized CUDU then runs on the general purpose hardware, which then connects to the rest of the network. I brought up automation and the Mavenir digital enablement layer earlier on, because with slicing and orchestration, these software components of the radio, supporting the multi-operator neutral host infrastructure, you can now use it to realize separate slices that we can dynamically enable and disable as required. So setup could be such that subscribers running on the MNO SIM, so T-Mobile or AT&T or others, they can stay on the MNO radio network. While Mavenir is a private network operator, we will have our users on the CBRS network when within the CBRS coverage area, but then when they roam out of the CBRS coverage area, they could actually connect to the roaming partner network. So it gives them coverage indoor as well as outdoor. A second use case that I want to talk about is OpenRAN slicing for advanced enterprise cases. So here, let's look at the use case that leverages automation tools that we just discussed. And it can be targeted for any public place under radio coverage that offers the opportunity for enhanced customer experience and hence can be monetized. To start with, this could be an enterprise, such as a mall or a museum that is a customer for the operator. And the operator has provided SLA-based priority treatment to its customers. Essentially, just like I go purchase a handset today from the operator and a plan along with it, in the future you see operators sell different SLA services. Similar to the SD-WAN concept, you have different SLAs for different slices. And the experience in this particular use case that I'm talking about is a premium only within the enterprise service area. So if I walk into a museum, I could get an enriched AR/VR experience. If I walk into let's say a mall, while I'm on the mall owner's coverage area, so for its footfall customers, you could actually get an enriched experience while visiting the mall. And the enterprises benefit in the sense that it then allows them to actually build monetization capabilities on top of these services for their customers. So I bring up this use case because traditionally you only talk about radio, only talk about core, but these are the different ways in which operators actually deploying OpenRAN, deploying packet core solutions that are all services based to realize the true benefit of 5G and how overall 5G network requirements in the application lifecycle management can be supported. So in this particular case, the radio is supporting different network slices. It's implementing slice SLA based on the aggregate bit rate for PDU sessions. The radio can actually sustain the aggregate bandwidth across all the users in enterprise A. So say it's the Galleria Mall in Dallas and you've actually sold the service to the Galleria users. When the user is actually within the Galleria Mall area, you could aggregate the throughput for those users within the area, or an alternative is you can even provide a per user based throughput guarantee and provide radio slice admission control and separation between the slices to be able to manage and provide the best quality of experience for the user who's visiting the mall. So these are some of the use cases we're actually prototyping and we'll be deploying soon with operators in the US and across the globe. And another use case is how we're actually doing the OpenRAN automated slice QoE and the SLA management that goes along with it. So as we discussed earlier, the OpenRAN solution leverages automation, cloud nativeness, and telemetry. And observability, telemetry or observability, these are the foundational design elements of the overall solution. AI/ML framework for telco actually provides different options for ingestion and learning. So here, one of the applications could be to detect the changes in traffic patterns and the different domain-specific clusters, and then take policy-driven actions for network adaptation to these changing traffic profiles. So what I show here is the framework for the Mavenir RIC, or the Radio Intelligent Controller. What is shown is the application of the RIC here using time series prediction to calculate a quality of experience with the different network slices that we discussed in the previous slide. The slice SLA management calculation is achieved through the service assurance solution, which then in turn uses feedback from analytic solution for closed loop network automation, and then providing a consistent quality of experience that can match the radio and core and transport SLA commitments that the operator has made towards its customers. So in summary, I'll conclude that OpenRAN is real. It's happening now. It's not something that's a pie in the sky. It's not something with a lot of promise for the future, as some vendors who claim support for OpenRAN states, but it's in fact happening now, and it's happening in tier 1 accounts. So OpenRAN has demonstrated support for large subscriber bases and is already meeting the network performance KPIs in both greenfield as well as brownfield deployments. There's been some discussion of performance impact with Split 7.2 that's raised for mobility and interference for massive MIMO radios. These are also being addressed, and we can expect more disruption and innovation from third parties for implementing the RIC and XApps and RApps. And finally, operators are deploying these OpenRAN solutions. They can also get the integrated service delivery experience from vendors such as Mavenir, who are the system integrator for these deployments. Thank you. Are there any questions?
Bejoy, that was great. Thank you so much. And I really appreciate you sharing the Mavenir story, the Mavenir perspective. And it's exciting what's going on with OpenRAN and Open Mobile in general. So I have kind of two bodies of questions. I have a kind of a set of technical and kind of set of market questions that I'm curious about. Maybe we start kind of with a little more technical, I suppose. You know, with this horizontal disaggregation of the RAN, RU, DU, CU, and whatnot. You know, I think that I'm curious about the interoperability and the supply chain, and you know, how much you're seeing of customers actually mixing and matching. And then I also saw, you know, an announcement with Mavenir and Altiostar. It looks like talking about some interoperability or trying to help kind of you know, speed up the availability of compatible RU units. So I wonder if you could share a little bit more there.
Sure. I'll talk about the activities which are actually public right now. So we start with Dish, for example, has announced Fujitsu as their partners for the radio, which means that you're already mixing the RRU with a third-party CU and DU. So far, I haven't seen deployments where the CU comes from one vendor and the DU comes from a different vendor, but technically there's nothing limiting you from having an open mid-haul. So F1 interface is open as well. There's no issue with having a CU and DU come from different vendors, but all the deployments that I've seen happen so far, whether it's the Rakuten deployment with Altiostar or Mavenir deployments that we have ongoing, the CU and DU itself coming from different vendors has not happened yet, except if the DU is actually part of you're doing a split 2 option, in which case the DU is part of the radio. That has been happening, no question there, but in a fully disaggregated model with the RU, the DU, and the CU separated out in a 7.2 and a 2 split 2 option deployment, not seeing that mix of happening yet. In terms of the ecosystem and the other question that you asked around the work that we're doing with Altiostar, I think this was to address one of the challenges that's specifically in the US market, where if you look at how OpenRAN ecosystem could actually evolve within the US market, one of the challenges that we have is the supply chain within the US market itself. So the problem there is the lack of US manufactured radios. So while the design capability actually exists within, the radios that are developed are in Taiwan, Korea, and China. So, but we really need low-cost US managed radio and manufactured in large volume as well, so that the radio pricing does not become a barrier to new entrants. And then also having these radios in the US frequency bands has been a challenge, because the traditional players would have had these radios developed in these countries that I just mentioned, and have those bands available, done custom for the US rural carriers or for the US markets. And the traditional, the third-party radio manufacturers, whether it's the MTIs, the KMWs, those sort of players, may not have the bands today for the US rural areas. So one of the things that we did with Altiostar, that announcement was about how do you build the radios to be truly open and address these band problem that we have for the US market alone. So that's the activity that we have. In addition, there's also the Facebook tip initiated activity to build the low-cost radios, sub-$1,000 radios. The Mavenir is participating in that, along with Parallel Wireless. And it also brings the ecosystem together. You've got MSC ODM or ACE Access. You've got manufacturing that's done through Foxconn or Flextronics. You bring in these ecosystem of players, which then allows you to widen the supply chain overall, which then at the end of the day leads to larger ecosystem. It leads to better performance as a disaggregated system because you could take advantage of the gains in the computational x86 as the CPUs. As the next generations of CPUs come across, you get better performance there. And any challenges that you have in performance or massive MIMO or more aggressive features in the radio side could also be addressed with the advancements in CPU. There's work actually happening in the OpenRAN space to see if some of the functions can be offloaded to GPUs. So that's another area as well where performance can be, any issues of performance can be mitigated. But so far, there's been no problem with actual deployments. The ecosystem has kept up. We've been able to maintain the KPIs, and wherever there are shortfalls in terms of not having the large scale radios available, we're actually addressing it through these partnerships and building these low cost radios with partners like Altustar and Parallel.
Okay, thanks. So, so it sounds like, interoperable RU with DUCU, that's happening both in terms of interoperability, deployments, and ecosystems driving the RU ecosystem. Curious about the DUCU split. So you said that you're not seeing any interoperability, or deployment models there.
Except for if you have a small cell sort of deployment, and you have the DUCU split, right? I think yesterday Rakuten was talking about the announcement, the massive MIMO radio announcement with NEC and Qualcomm. That's one case where you have the DU also as part of the radio. In that case, you're doing a split 2, and there you've got different vendors. But I was talking about a case where you truly split out the RU, you have a 7.2 split on the front haul, and then you're doing a DU with a split 2 from the DU to the CU.
Okay, good, thanks, got it. Makes sense. So, I guess a related question is, what, you mentioned GPUs, what do you see the need for accelerators in the DU, and what's Mavenir's strategy around, it being generic x86 versus a sort of specialized platform?
Yeah, so, the whole prospect of GPU is that you get parallel processing can be done a lot better on GPU. That's the idea. So from our perspective, we're evaluating alternate technology for RAN. It's to capture the wider ecosystem, and it includes GPUs and lower cost. The objective here is that you can support more cells per server, and it's primed for locations like LDCs or the local data centers, and not at the cell site alone. The cell site alone may not have the density that's required to support very large number of sectors, right? So as you want to increase the number of cells per user, the density sites, the capacity sites, these are good options where you can actually offload the capabilities of the DU to a GPU. And similar consideration for edge and private network deployments, where you actually have to have the UPF plus the CUP plus functions like edge analytics run on a GPU. So in those cases, you could actually, we believe that you could lower the cost of operation because the total TCO could be lowered because you're running many of these functions together on the GPU. So, for example, the one public announcement has been with NVIDIA, right? So NVIDIA has been talking about the Aerial SDK, which they claim supports a lot more cells per sector, and the total cost can be lowered. There's also debate in the industry. Players will have one position versus GPU players will say you could do all of this, but it's definitely promising, and it's something that we're working on as well. A good example are these edge deployments, these density sites, these capacity sites, where many of these functions could be offloaded to GPUs.
Great, thanks. So Bejoy, thank you for that. So we talked about that horizontal disaggregation, RUDU-CU. Now, next, I'm kind of curious about the vertical disaggregation, starting to extract some of the functionality out of the CU and the DU and move it up into the RIC, DEXACs, RAPs. It sounds like you mentioned that, and you have a RIC and you have something. Curious to hear a little bit more about maybe your ambitions, the timeline, and then the Mavenir position on moving, the more complicated or latency sensitive functions, the RRM functions, like a handover kind of function, up into an XApp. Where's Mavenir on that journey?
Yeah, so from Mavenir perspective, definitely we believe that innovation will happen in the whole OpenRAN space through the RIC. That's because that allows you to bring in third-party apps, whether it's the near real-time or the non-real-time RIC kind of applications. At least from the industry perspective, the first thing that we see happening are more use cases around traffic steering, antenna tilt optimization, QoE guarantee, those sort of initial SON kind of use cases, whether it's CCO or MLB, FPT kind of use cases, is the first delivery for RIC applications. Then we see slicing, the slice manager function actually ride as part of the near real-time RIC. That's another capability that we see. The third part to this is the mix and match of the near real-time RIC and the non-real-time RIC itself, right? So having an open A01, actually open A1 and E2 interface, that's key in our position. And the way we think of this is in our pedigree, we've delivered a lot of voice products as well. And when we think of RIC, it's almost similar to the old SCP, the SCP-IN model, where you had a call state model. You would interrupt, go externally to the SCP, get an action executed, and come back, right? It's a similar model that you see here for the RIC as well. So it's doable. You could move functions out of a composite box, move it externally into a RIC, and innovate just like you innovated on IN applications on the SCP. You could do the same thing here with the RIC. So we believe it's doable. In terms of actual moving out RRM functions and realizing those and resolving conflicts between the different RRM functions, some running on the radio itself, the software part of the radio, and some running on the RIC. These initial use cases we're seeing, it's actually able to achieve it. There are some more complex use cases which we have to try out, and there's more optimization required to realize the execution of those functions within the same control loop criteria that's been set for near real time, right? You don't want going externally to become the bottleneck, and especially as you scale out the solution and have to support a large number of CUs under one RIC, you don't want scalability to be the mitigating factor. So we're considering all those aspects as we look at a RIC in our solution set, but definitely in terms of solution and applications that we will deliver, we'll deliver on XApps and we'll deliver on RApps as well. Our objective is to keep our radio open, have open E2 interfaces, and have open A1 interfaces.
Good, thank you. Thank you for that. So let's switch gears a little bit, talk a little bit more about the market. So, you shared some of your customers and footprint and whatnot, and that's great. And you also touched on system integrators, and that's something that comes up frequently in all the different sort of vertical domains where disaggregation and open source has started to be introduced in telco environments. So, I guess one thing I've seen in different markets is that there are different classes of system integrator. Some are good about climbing telephone poles and deploying hardware, and some are good about putting software pieces together. And so I guess I'm curious in your journey in finding system integrators that can really put the various components together. Are you starting to find, or are you starting to find a need for software skills in the system integration pool, and are you, what's your view on that?
Yeah, so I'd say you're right. There are these players who are good at actually laying out the fiber, the ones who are laying out the tower, they're good with actually doing the drive testing. And one of the things is many of the system integrators are common and used today by the larger players as well. So the Ericssons and Nokias are actually using the same sort of system integrators under the hood. They may not be exposed and be through a third party. And we are also signing up with these similar players in this space, whether it is GDT and others, or working with the traditional players like Techem and Infosys and others. As an industry, we don't believe there is a challenge to actually addressing the space. Mavenir has been delivering this as a system integrator as well. So overall, our view is that this is a problem in some cases, maybe for specific markets, because you cannot find the right skill set to actually go to do a deployment on a very large scale. But it's something which can be addressed over time, at least for the markets that we are operating in. And we're focusing on right now. We've not seen the challenge of lacking skill set from a system integrator role perspective to be able to be successful in delivering our OpenRAN solutions.
So today, when you do have customers mixing and matching an RU and your DUCU, who does that integration, and then who takes responsibility for the final solution? You know,
integration, we are responsible for the final end-to-end SLA for that solution delivery. I mean, good example is take Dish, right? So Dish is publicly announced a vendor. So first effort becomes we work out the ORAN IoT profile with these players, then we take it to the lab. We go through a full integration testing with them, make sure that all the test cases, the receiver sensitivity, the performance, the KPIs all match what is needed. Then we work together with, if it's a third-party automation framework, in the case of Dish, they've announced VMware as the automation provider with the orchestrator and the container platform. So then we make sure that the Mavenir CUDU software, the RIC and other elements can run on top of that software, have a full ZTP or zero-touch provisioning, manage in this environment. And so that's what happens initially as part of making sure that the solution set comes together. Then in terms of deployment, again, Mavenir is the one who has to make sure that the overall solution KPIs are met. Before the solution goes live, we have to make sure that whatever the operator has in terms of their KPIs and contract or is actually getting from their current incumbent for brownfield kind of deployments is met by Mavenir. So we are on the hook to deliver that, and that's how it's worked. Just like it's the way it's worked for replacement opportunities for IMS in the past years, it's the same thing we see for the radio deployments as well.
Mm-hmm. Yeah, so in many ways, Mavenir is playing the system integration role. You know, you've got system integrators doing a lot of the physical deployment, but you're doing a lot of the logical integration and taking ownership of the solution, it sounds like, yeah. Okay, that makes a lot of sense for the stage that disaggregation is in right now in OpenRAN. Very good. So maybe the last question is around, you know, this open movement. I'm sure you see, you know, FUD is kind of the classic word in the industry, fear, uncertainty, and doubt. And people raising concerns about the whatever it is, the scalability, the reliability, how real OpenRAN is, and is it performant compared to more classic or traditional solutions? So wondering if you could share a little bit about you know, what you're seeing and what you think the reality is from Mavenir's perspective.
Yeah, I mean, like you said, there's a lot of FUD, and that's thrown to see if OpenRAN is actually real. Is it only something that's happening in greenfield deployment can actually meet the same KPIs in true brownfield deployments, right? So one case that I can talk about, which is public, is Vodafone in India, in Bangalore. Today, we've got sites that are live, which actually have to meet the same KPIs as the incumbent vendor. And when we started off, I would say that the KPIs were off. That we were, whether it was the LT call drop rate, or whether it was the uplink and downlink throughput, or the VoLTE call setup rate, the LT call setup rates. There were some differences that we had initially, but now we are on par with what was required by the operator with this is a tier 1 operator, and it's running within a brownfield setup, right? So it's not like you could certainly go in and expect degraded experience with their customers. There's absolutely no way they would allow that. So I'd say in terms of actually having met those KPIs in brownfield through the rigorous testing that we've gone through in multiple of these deployments, we're actually there on 4G. On 5G, the same thing will happen. I cannot claim that we there's live 5G deployments at the radio yet. Dish would be a standalone 5G deployment that will happen this year. And we are in the process of vetting all the KPIs with them and making sure that we can meet those requirements. But in the lab and field trials, we're already meeting the KPIs that's required for these tier 1 and tier 2 operators.
Yeah, great. So can you share a little bit more about Dish you just mentioned? So, you know, what's been public about Dish? You just mentioned a little bit about timeline. You know, what are the aspirations and what's, you know, Mavenir's role in the Dish deployment?
So Mavenir, I mean, what's been publicly announced is Mavenir was the first selected vendor for the radio. Actually, the first vendor that they selected for anything was Mavenir. And they selected us for the CU, the DU. And today we're working with a couple of radio players that they've announced publicly. Fujitsu is one vendor that they announced publicly. So we're working with Fujitsu. And there are a few other opportunities we're working with them on. So the setup is working with them on the radio, making sure that it runs on top of VMware's infrastructure. So VMware is another party that they announced a couple of weeks ago. And their ambitions are to actually go after the enterprises, go after become the disruptor like T-Mobile was. They want to be the player who brings new services fast. So Mark Ruan, Stephen Bai, and others talk about Rakuten as one operator that they've looked at in the past to see and take some of those learnings. So to them, automation is key. And that's why another part of my presentation was not just about the radio and meeting the performance numbers there. It's how do you actually leverage automation, CI/CD, DevOps kind of tools to make sure that you could actually roll out these networks much faster, be able to run new services on top of this network, and hence monetize it, right? You'll hear Tariq from Rakuten talk a lot about how much less time it actually takes for Rakuten today to roll out one of their sites. He talks about metrics like 8 minutes and 6 minutes and how the time has been reduced. So we've got similar targets and more aggressive targets that we have to meet, and we are meeting for the Dish delivery as well. And all of that is possible through automation. And unless we had this microservice cloud native based solution for our OpenRAN radios, OpenRAN, CUDU, and having interoperated with these third-party RRUs, we wouldn't be able to meet those aggressive targets that Dish has set for Mavenir.
Okay, great. Well, Bejoy, I want to thank you very much for joining us today. This has been terrific. A great insight into Mavenir and what you're up to in the space. So thank you for joining.
Sure, and happy to have joined the session, and thanks for the conversation.